English for engineering.
Tiếng Anh ngành kỹ thuật.
2.1.
The only way to assess the environmental impact of a given material properly is to carry out an environmental audit and analyze the total impact of that material on the environment. I emphasize total impact because it's all too easy to judge materials and products on single aspects of their ecological impact. As an example, if we compare traditional and energy-saving light bulbs, it's tempting to say energy-saving ones are better because they consume less energy. In fact, that's only part of the picture. That's just the in-use phase. You also need to consider the pre-use phase. In other words, the environmental impact of mining the materials used to make the bulbs, of transporting those materials to the factory, of manufacturing them, etc. Then there's the post-use phase. How easy is it to recycle spent bulbs? And when you start to consider all of these factors, suddenly the comparison between classic bulbs and their energy-saving equivalents becomes much less clear-cut. Some of the materials used in energy-saving lights are problematic from an environmental standpoint, both in terms of acquiring them and recycling them. So the point is, it's essential to look at the whole picture. And doing that can be quite a complex task, as we'll see later on in
2.2.
Okay, so steel bodywork versus aluminium bodywork.
What about pre-use then?
Well, I think it takes a lot of energy to produce aluminium compared with steel, because aluminium's made by electrolysis.
Yeah, so steel's better, presumably.
I think so, yeah. But hang on a minute. With aluminium, it depends how much is derived from ore and how much is recovered from recycled material. As far as I know, recycling aluminium takes less energy, so I'm not really sure.
Presumably it'll be mixed, won't it? For a given batch there'll be so much new material and so much recycled material.
Probably, yeah. Okay, so that needs to be researched then.
Is car bodywork galvanised when it's made from steel?
Oh, good question. I'm not sure.
If it has to be coated with zinc, then that would take extra material and extra energy, so that's an important consideration.
True. Okay, so that's another question to note.
Then there's the energy consumed when they're transporting bulk metal to the car plant.
Presumably aluminium takes less energy to transport, being lighter.
I'd say so, yeah.
Okay, what about manufacturing?
Well, aluminium would be lighter to handle, wouldn't it? It probably takes less energy to cut as well.
Yeah. Not sure whether it takes less energy to weld compared with steel.
Good question. Another thing to check out.
What about in-use then? I assume aluminium's better because it's lighter, so you consume less fuel.
Yeah, and it should last longer as well.
Is that an environmental consideration, though?
Well, yeah, because if things last longer, they need to be manufactured less often, so you use less energy.
True. But then, is the lifespan of a car determined by the life of its bodywork?
Good point.
It's usually determined by the chassis, or the engine, isn't it?
Is it?
Another one to be researched.
OK, what about post-use then? 2.3.
So, in terms of the main components, the conductor at the center is copper or aluminium, depending on the model. That's then coated with polyethylene insulation and surrounded by steel wire, which provides the armored protection. As the steel obviously needs to be protected from moisture, there's a plastic waterproof membrane around that. Then the whole thing's surrounded by an outer jacket, which, again, is in plastic-based material.
2.4.
That's certainly a scary-looking collection of tools.
Yes, some of them do look quite menacing, don't they?
Is that titanium? The drill handle?
Yes.
I'm an engineer. That's why
Oh, I see. Yes, titanium's great. It's expensive, obviously, but very light. That's the big advantage. Ideally, you want it to be lightweight to give you better control. These are the most impressive things, though. The burrs on the end. The latest ones can rotate at over 500,000 revs per minute. They're coated with tungsten carbide, which I think is one of the hardest materials in existence, isn't it? Along with diamond. That's also used. The key requirement is abrasion resistance, of course. Obviously, they need to be very durable. And you don't want them snapping either. The last thing you want is a brittle material. Apparently, that was the trouble they had in the past, making the burr tough enough so it didn't break. I think part of the problem was heat as well. Drilling into a tooth at high speed, you obviously get a lot of heat buildup. You need a good degree of thermal stability. See what I mean? You can actually smell burning. And that's after a few seconds. Imagine the heat buildup after several minutes.
2.5.
Speaking as an engineer, Louisa, my view is that all the materials we use should be genuinely suitable for making watches, and not just chosen as marketing gimmicks. We're often guilty, in my view, of using exotic-sounding materials that are not particularly suitable from a technical standpoint.
Yeah, I know what you mean.
A good example was that debate we had on whether to use submarine-grade steel in some models, to give the impression that they're exceptionally resistant to water. Okay, submarine steel's good at withstanding the pressure of being a mile beneath the sea, but it's heavy. If it's not coated, its corrosion resistance is not that good, at least compared with other metals like titanium. It's also fairly poor in terms of looks, in my view. Water resistance isn't a question of metal quality. It's about the quality of the joints and seals you use. So, as a watch material, for me, it's not at all suitable. Tremendously marketable, I'm sure, but...
No, I take your point. But I think it's fair to say that we've never chosen a material for marketing reasons that's insufficiently durable or not adequately built in any way.
Oh, no. No, if anything, it's been the reverse. We've used materials that are over the top, so they can be described with superlatives in advertising.
Ideally, we should be using stuff that's good for watches and good for marketing as well.
Sure, but that's easier said than done. I mean, a lot of the materials that are ideal for the job in terms of scratch resistance, shock resistance, and all the rest of it are either pretty ordinary or their compositions are relatively complex. And they've got complicated names, which means they're not all that good for marketing. That's the problem.
Sure, but the other problem is consumers are not technical experts and they make choices based on their impressions rather than based on facts. That's a hard commercial fact. As hard as submarine steel.
No, I accept that.
So what should our approach be? It's obviously not an easy question.
2.6.
1.
Not particularly suitable.
2.
Exceptionally resistant.
3.
Not at all suitable.
4.
Tremendously marketable.
5.
Relatively complex.
6.
Not all that good.
Ngoại ngữ chuyên ngành.com